Hi everyone, this video is on question 8 from exercise 1D of Pure 2, which is on quotient rule. So this is an interesting question because if you look at the function that you're given, it's slightly different to the usual type of functions that we have in differentiation questions. So let's get started and see what we can do. So we have a function or a curve that this is the equation. So that's e to the x is equal to e to the y 3 plus 2y. So the reason I said it's different to the typical functions is because we have the function in terms of y, which is not very common. So for part A, that's a very simple question and we need to use our knowledge from GCSE. So we want to find the coordinates of the point P where the curve cuts the x-axis. So basically, when the curve cuts the x-axis, y is equal to 0. So it's just a fact. And now we already know the y coordinate of P, we just need to find the x coordinate. So we just substitute y is equal to 0. So when y is equal to 0, we have x is equal to e to the 0 divided by 3 plus 2 times 0, which is 1 over 3. So the coordinate of point P is 1/3 0. So this was the first part, which was very straightforward. And in part B, we need to find the equation of the normal to the curve at point P. And then give your answer in that form. So obviously, you know what to do because you have seen questions like this in Pure 1. So you know there are steps. You need to differentiate the function, find a gradient, then find the gradient of the normal, and then use the general form of the equation of a straight line to find the equation of the normal. But the only thing here is that the function that we have is written in terms of y, and we want to differentiate this. So as usual, when we do dy dx, we can't do that here because the function, is not written in terms of x. What you need to remember in questions like this is that we have a nice relationship which says if you do 1 over dy dx, this is going to be equal to dx dy. So this is a very important relationship. So when we can use this relationship, basically whenever we are given a function like this question that is written in terms of y, so what we can do is that we can find dx dy. So we just differentiate with respect to y, and then if we find a reciprocal of this side of the function dx dy, then that is dy dx basically. So that's how we can attack this problem. So now let's find dx dy, which is something that here is easy. So dx dy is equal to, okay, so as usual, this is the quotient rule, and by this time you should be comfortable with the formula. So we square the denominator, which is 3 plus 2y squared. That's the first step. And then we write down the denominator function times the derivative of the numerator function. So numerator is just e to the y. So e to the y differentiated is just e to the y with respect to y, obviously. Take away. Then e to the y again, because that's a numerator function, times the derivative of the denominator function. So denominator is 3 plus 2y. Its derivative is just 2. So I don't need brackets really. Just 2. And we can simplify this just to have a nicer form. So in denominator we have 3 plus 2y squared, and the numerator is going to be we can take a factor of e to the y. It's very common in quotient rule question to to factorize the numerator. So we are going to get 3 plus 2y, then the next bit is minus 2 actually. Okay, at this point we can use this relationship, which basically is saying that if you have dx dy and you want to find dy dx, you just find the reciprocal of dx dy. So dy dx is equal to the reciprocal of this fraction, which is just e to the y times 3 plus 2y minus 2. This goes to the denominator, and then the denominator goes top, which is 3 plus 2y squared. Okay, now this is the interesting part, because typically when we find dy dx, we substitute x into dy dx to find the gradient. But here the problem is that if you look at dy dx, it's written in terms of y, so we can't substitute x. But what we can do is actually substituting y, because we have the point, right? So the point is here, 1/3 0. And since this function is, in terms of y, we just substitute the y coordinate, which is 0. So when y is equal to 0, then dy dx is equal to, okay, we just substitute 0 into dy dx. 3 plus 2 times 0 squared e to the 0. 3 plus 2 times 0 minus 2. So we can simplify that now. So the first bracket is just going to be 9. Then in the denominator, we are going to get basically 2 times 0 is 0, 3 plus that is 3, 3 minus 2 is 1, 1 times e to the 0 is also 1, because e to the 0 is 1. So overall, the gradient is 9. The gradient of the tangent to the curve. So this is the gradient of the tangent, but remember that the question is about finding the gradient, finding the equation of the normal. So we know that the gradient of the normal is the negative reciprocal of the gradient of the tangent. So the gradient of normal is minus 1/9. Okay, now we know the gradient, we know the point, which is 1/3 0, just to double check. Now we know we have the gradient, we have the point. Let's just find the equation of the normal. So we use this form, y minus y0 is equal to m times x minus x0. We just substitute the values. Y minus y0 is just 0. M is minus 1/9. And then x0 is 1/3. So it becomes minus x/9 plus 1/27. And that's it. So this is the equation of the normal. And this is exactly in the form that we were asked. So yeah, another thing is that always basically be careful what form you want to give your answer, because sometimes the form that you're more comfortable with is not the one that the question is asking you. So always check what the question is asking. Okay, that's it for this video, and thank you for watching.